Alright, welcome to section 10.4, which is dealing with an ellipse. This may be the first time you've ever had to deal with an ellipse. It's sometimes in the Math 120 coverage, intermediate algebra coverage, so you may have seen it before. But the basic form of an ellipse is an x squared over a squared plus y squared over b squared is equal to 1, where a is greater than b. So notice both the x squared and y squared are both positive terms. That'll be different when we go to the hyperbola. And so in ellipse, both of the x terms and y terms are positive. We need to have a perfect square over a squared and a perfect square over b squared. And this 1 is super important that's over here on the right hand side. It has to be equal to 1. Now he's going to separate this into 2 points. He's going to make a greater than b. So a is the thing under the x. If a is bigger than b, then what's underneath the x squared is bigger than what's underneath the y squared, which means it's more elongated in the x direction. So we say x is the major axis. So if we read here, the center of the ellipse is at 0, 0. Let me show you where it wouldn't be at 0, 0, so that would make sense. X minus 3 squared all over 16 plus y minus 2 squared all over 36. Not 36. I need to make that less. Apologize, I'll keep it in its right form. So we're going to keep that x the major axis. So if I put something under here like 9, then x is the major axis. The center here is at 3, 2. So now you can see why the center is at 0, 0, because nothing's being taken away from the x, nothing's being taken away from the y. And so the ellipse has x-intercepts called the vertex. Well, they're vertices, right, because there's 2 of them, on the major axis at negative a0 and a0. When a is greater than b, the vertical axis is the shorter axis, is then called the minor axis. And the y has intercepts called vertices on the minor axis at 0, negative b, and 0b. And then the foci are always along the major axis. So whatever number in an ellipse has the bigger number, whatever variable has the bigger number underneath, that's where the focus is moving, along that major axis. And what f squared is, it's a squared minus b squared. So how I remember that it's minus, I always remember that it's a squared and b squared because it's like the Pythagorean theorem. How I remember that it's minus is the focus has to be inside both a and b, because it's got to be inside the ellipse, the 2 focus points. And so those focus points are actually how the ellipse is drawn. I don't know if he's going to get into that. Let's see what we have here. The other one is if the major axis is along the y-axis. That's where the b is going to be bigger than a. And so the center of the ellipse is at 0, 0. When b is greater than a, the major axis is the y-axis, and you're going up and down on the y-axis. The focus points are along the y-axis as well, because that's the major axis, and then you can get the minor axis. So he's defined as f in such a way where you can always write it as a squared minus b squared in the absolute value there. So we'll take a look at that as we go forward. So that's the basic introduction. Let's just put it to practice, right? So here's example 1. So it looks like, this is example 1 over here. So let's take a look at this guy where there's actual numbers underneath. So you can see the 25 is definitely bigger than the 16. So everything is happening along the major axis, and the major axis is the x-axis. Because nothing's being added or subtracted from the x or the y, the center is at 0, 0, right? And the major axis distance to the vertice is 5, the square root of 25. And so you're going to go out along that major axis a distance of 5. Now what 5 is, it's the square root of what's underneath. It's the square root of the larger number, and you're applying it to the variable that it's underneath. You're going to go up a distance of 4 in the y direction to get the other 2 vertices, so you get that elongated oval shape. And then to find the focus points, that's not on here, so we're going to go through that together. It's down below, I'm sure. The focus squared is always a squared minus b squared in the absolute value of it. So 25 minus 16, what does that leave us? That leaves us a distance of 9, and the absolute value of that is 9. So what's f? F is 3, right? And we can see that being worked out down here. F is 3. So you're going to go along the major axis out 3 units. 1, 2, 3, and put a dot right there. And those are going to be your 2 focus points. We can see him do that down here, but we might as well talk about it up there. Okay. The reason why he's using those absolute values, it might seem really dumb, it's so that he doesn't have to readjust it when b is bigger than a. It'll all work out the same. So let's look at example 2. So in example 2, he's got a little bit of an issue. He has, this needs to be a y right here to have it make sense. So that he's just a simple mistype there. You can see that the bigger number is the 169, so the major axis is the y-axis. And we're going to go 13 units up and down from a center point of 0, 0. Hopefully you see the centers at 0, 0 really quickly. How come the center's at 0, 0? Because nothing's being subtracted from the x or the y. We're going to go 13 units up, 13 units down to get the major axis, and we're going to go 12 units out on the x-axis. And so you can see he's got it super elongated. It's more of a circle than what it appears there. And then to get the focus, he hasn't shown the focus derivation yet, but he has the focus in there at 5. Let's see where he does that, right down here. So he's following perfectly his a squared minus b squared absolute value. 144 minus 169 is 25, but negative. Absolute value, so this is negative 25 working out of there. Absolute value is 25, square root is 5. And you're going to go always along the major axis, never the minor. So whichever ones went out the farthest. So try to put as much intuitive thought in it as possible as you're working through these. Now he's going to have some examples where the center is not 0, 0. And so this is super important that you remember who's who. So our center here now is at negative 2, 0. Do you see that happening? I don't know where he mentions that. Right here he mentions is at negative 2, 0. But we know that from our work with the circle. The 169 is the bigger number. It's underneath the x. Everything's happening to the x. So we're going to add and subtract 13 from the x in order to get our major axis length. So we're going to go out 13 from negative 2, 0. So we're going to be at 11, 0 and negative 15, 0. So he doesn't have this in a grid, unfortunately. If he did, the x-axis would be back in here where he's at negative 2, 0. And then from that center point, right, not from the origin, you can get your y height by going up and down 12, right? And our focus points are going to be along the x-axis as well, or in the x direction. And again, it's going to be 5 coming out, and you're going to make sure you add and subtract those from the center point, not from 0, 0. 0, 0 is the origin. 0, 0 was the center in the previous examples. Here it has no bearing on the ellipse itself. It just has a bearing to help us figure out where we're at. So again, our focus is 5. So we're going to add and subtract 5. So we've got negative 2, 0 as our center. We're going to add 5 to it and subtract 5. Adding 5 brings me to 3, 0. Subtracting 5 gives me to negative 7, 0. And so you can see putting those points in there. Here's negative 2, 0, that's our center. 5 up is 3, 0. But we went a full 13 out, right? It doesn't really look to scale in there. 5 out, and we went a full 13 out to get here. This was a distance of 12. And the only reason that they are flat out 12 is because there was no adjustment in that y height. The center point was still at 0. So pretty good examples. Here's the next good example here, example number 4, where we're looking at something that has both an x and y change. So our center is at positive 3, negative 2. He has that represented right here. You can see that the major axis is the y-axis, so you're going to add 10 and subtract 10. Think about that. If you add 10, we're going to get a high value of 3, 8. And if you subtract 10, you're going to get 3, negative 12. Let's go see those points. Here's 3, 8. Here's 3, negative 12. We got to go get, well, we could get the other one. Here's 64, square root of 64 is 8. So you're going to get your minor axis vertices by taking the 3, negative 2, and adding and subtracting 8 from the 3. So 8 plus 3 is 11. 8, so 11, negative 2 is a point on the ellipse. And if I subtract 8, I get a negative 5, negative 2, right? Still at that same center line. And so we're just moving straight out in those directions. We move straight up 10 and down 10, and we move straight out from the center point. We got to figure out our focus point. Let's see where he does that. It must be right down here below. So our focus point is the absolute value of whatever 64 minus 100 is. We know that the difference there is 36, but it's negative 36 technically, right? But we're taking the absolute value, so we get a 6. And so negative 2 plus 6 is positive 4. Negative 2 minus 6 is negative 8. And so you get these two focus points right there. And that's it. You're just graphing those guys out. More and more examples there, right? If we just look holistically at this one, you know it's going to be elongated in the x direction. It's longer there. Y, we're going to go up 8. Center is at 3, negative 1. That all looks correct. 10 out in the x direction, right? 3 plus 10, 13. 3 minus 10, negative 7. You can see all these numbers just working out. So I'll let you study that. Focus of 6 coming through there, and so we get that focus point in there along the major axis. So that 6 gets added to whatever variable has the bigger number under it, and that's the x. And so that's why 6 is being added and subtracted from the 3, but staying on that negative 1 y height level. And what we have is just more and more examples of this. Let's see if there's something new in here. So this is a good one. You're going to have 3 pieces of information to determine an ellipse. And so some of the examples are going to give you center points and focus points and a vertex at 7. So let's see what we know. And then we'll kind of read through this. The center is 0, 0. So you know right away already it looks like this. It's an ellipse. So you know it's x squared, y squared equals 1. The reason why I know there's nothing being added or subtracted is my center's at 0, 0. So I've taken care of that. I got a focus at 5, 0. I'm going to park that kind of. But it does tell me that the x-axis is the major axis. And so the 7 tells me how far I move. So this is a 49 under here. Awesome. What I do know is that my focus length is 5, so I know that f squared is equal to the absolute value of a squared minus b squared. I definitely know that my a squared is 49, but I don't know my b squared. And so let's take a look at what b squared is going to be. So let's watch him do this. So he says f squared is equal to a squared minus b squared. He puts in the 7. 49, right? Here's the 5 squared coming through. Then he moves things around, so b squared is equal to 49 minus 25. So b squared is equal to 24. Now, it's only b squared that you need. You don't ever need to know out what b is, because remember what the formula is. It's x squared over a squared plus y squared over b squared is equal to 1. So you can figure out the b squared and be done. And that's why he's just dropping the 24 under there and not adjusting it at all. Another one where the focus is at 0, 0. Where the center is at 0, 0. So we now know it's an x squared plus y squared. We know that everything is happening in the y direction because of the focus and the vertex. We know that 49 is underneath there. And we also know, and I'm interested to see how he's going to handle this. Okay, he's going to use the absolute value coming through. And so, interesting way to approach this. So, you got an a squared there. Sorry, there's different ways that different books will handle it, and I just wanted to see what he pinched himself into. So we know b squared is 49, we know a squared is less than b squared, and f squared is 36. So, because, did you see how we knew that? the f distance was 6, and so f squared is 36. So we have that formula that I was going to use earlier. And we know a squared is less than 49. So you got to be careful how we solve this. So this is 36 is equal to the absolute value of a squared minus 49. So I need to figure out what I could put in there to get really a negative 36. And what he's witnessing is that a squared is equal to 11. And I agree with that. So it gets a little bit weird if you try to solve it from this perspective. But we absolutely know that a squared minus 49 could either equal 36, which it can't. That would make a squared bigger. Or a squared minus 49 would be equal to negative 36. And when you add over the 49, what do you get out of that? I think you actually get a 13, not an 11. Let's check that out. What's 11 minus 49? 11 minus 49 would be 38, not 36. So he's got a mistake here. This should be a 13 coming out of that, and I'm glad we checked. And so this is not an 11. This is a 13 coming out of there. So not sure how he did that, but I hope you're okay with how he came up with that. Since the absolute value is equal to 36, a squared needs, this a squared minus 49 needs to be negative 36 right over here. Gets a little bit dicey with that. I always just do it with the higher minus the lower, but I'll stick with his examples. Here the vertexes are negative 8, 0, and 8, 0. So we learn right away with the 6, 0 that everything's happening in the x direction. We can find out the midpoint between negative 8 and 8 and realize that the center is at 0, 0. And we know so much. We know the exact same information. Now we know it's x squared plus y squared is equal to 1. We know everything's happening to the x, so the 64 is right under here, and we're looking for the b squared. We know that f squared is equal to a squared minus b squared. I'll put the absolute value, but in this case we know the a squared's bigger. So we know f squared is 36 is equal to 64 minus b squared. So b squared is equal to 64 minus 36. And if we look at 64 minus 36, right, and he would have done the same thing down here, we get a 28 coming out of that. Yeah, 28 makes sense. And so what he's going to do is put that all together to get a 28. You'll get really fast at this, but it's a good calculus type of thing to take given information and figure out what you know. Here we have a focus and two vertices. So the vertices, if you look at their midpoints, the midpoint has to be the center, and the center then is at 2, 0. If you look at 2 plus 2 divided by 2, we get 2. And then right in the middle between negative 5 and 5 is 0. We know that everything is happening in the y direction. And so we know it's x minus 2 squared, right? Because it's a negative 2 plus, it's a positive 2, so it's going to be a negative coming out of there. Y plus 0, so I don't even need to do anything more than just do a y squared equals 1. And we also know that a 25 goes under here, and we're looking for what he calls the a squared. And so we're going to go through that process. Remember, a squared is smaller. So what do we know about f? F is the distance between the center and the focus, and so f is 4 for us. So 4 squared, or 16, better be equal to the absolute value of a squared minus b squared. But we know b squared's 25. We have to remember that a squared is smaller, and therefore we're looking for a squared minus 25 not to be 16, but to be negative 16. And so if we add 25 over and think about the distance between 25 and 16, we get a 9. And so well, that's all we needed. We needed to know what a squared was. A squared is 9, and let's see that all work out for him. A squared's 9, and then we get that nice formula there that matches. Super fun. And so this is just going to continue and continue. Here's another example of it. Here, the center point, the 2's are the same, so the center is right in between 5 and 8. 8 plus 5. Interesting. Let's see what he does. Oh, the center's at 5, 2. I was reading that wrong. Center's at 5, 2. A vertex is at 8, 2, and a focus is at 10, 2. So he's going right back to some of the earlier ones. So what do we know? We know it's x minus 5 squared right away, plus y minus 2 squared right away, equals 1 right away. Then we're looking to see how are things moving. Oh, they're moving along the x-axis. They're moving from, the vertex is moving a distance of 3, right? And so we got a 9 underneath here. And then the focus is moving a distance of, oh, the focus is moving farther. So he has these labeled backwards. You can see, at first I was just like, that can't happen, and it cannot happen. So notice the focus distance is farther than the vertex distance. He fixes that here as he goes here. Look at those are reversed. So this needs to be the vertex, and this needs to be the focus. So it's not a 9 underneath there. It is, well, the distance between 5 and 10 is 25, right? And our F distance is the 3 that we thought our distance was there. So interesting. So let's see if he fixes that down here. Minus 5, minus 2. Okay, vertex at 10, 2. So we're looking good there. So what do we know? We know that 9 needs to be equal to a squared minus b squared. So b squared is equal to 25 minus 9. So b squared is equal to 16. And so we're finished. We should just be able to put the b squared underneath there. So the center's at 5, 2. A is not 10. I'm not sure where he's coming up with A being 10 at. So this is all wrong down here. A is not 10. A is 5. The distance between 5 and 10 is 5, not 10. A squared then would be 25. So this is a 25 under here. And because he had that mistake, the B squared is a 16 under here. And so there's a few mistakes in there as well. But luckily we did it on our own. So there's lots of crazy labeling in that last one that caused it to be a problem. And then he got really confused because sometimes he's calling A 8, sometimes he's calling it 10. It would only have been 10 if the center's at 0, 0, which it's not. So there's a little bit of an issue here with this very last example. So I'm grateful that we're doing this video.